Okay, so here we have a basketball player. Basketball player releases a shot from a height of 2.3 meters towards a 3-meter high basketball hoop. If the basket attempt is released from an angle of 36 degrees from a distance of 5.5 meters from the center of the hoop. So here we go. I'm going to go from where it releases it and in the direction to here. It's kind of a little annoying, but this right here is 5.5 meters. And then also let's pick a different color. Let's go with blue. From here to, let's say, the ground, this is 2.3 meters. And then from here to here, this is 3 meters. So one real quick thing to realize is that in the x direction, our dx, this object travels 5.5 meters. Our dy, though, on the other hand, is going to be the difference between these two heights, because if it just went 5 meters in the x direction, it'd be right here. But it also has to go up a value. Now, the value is the difference between these two heights. So in this case, it's 3 minus 2.3, which is going to give you 0.7 meters. So that gives you your two d values. Now let's go over to another worksheet and expand upon this. So this is something very important, guys, and hopefully you've got this memorized by now. But vectors can be described two ways, with their x and y components and with their length and angle. And to go in between the two, you need these formulas. So you need vx equals v I, or v cos theta, and vy equals v sine theta. And it could be vi. It doesn't really matter. Hopefully you got those memorized. Now let's start talking about things, because I want to get this done as quickly as possible. We have our x values and we have our y values. So in the x, we have a velocity in the x direction, and this is talking about initially. We have a vxi equal to vi cos theta, and we have a vyi equal to vi sine theta. We also have a d equal to 5.5 meters. We also have a d, and I'll call this dx, dy equal to 0.7 meters. Notice it's positive, that's very important. We have an a equal to 0 meters per second squared, and we have an a equal to negative 9.81 meters per second squared. Okay, so we've got that. Now let's go back and let's combine these, because we do have a shared term between both axes, and that is going to be our time. So both these have a shared term of a time. Once again, it's very important to remember. Okay, so how can we find this time? Or how can we do anything? Well, the first thing is to make a system of equations. D equals vi. I'll do the x. T plus 1/2 ax t squared. Okay, now let's plug in our d values. This is 5.5 meters equals, which is going to be vi cos, I think it's 36 degrees. I'm putting in parentheses, times t plus 1/2 dot dot dot. This is actually, this whole thing that's going to happen here is going to be 0. So just ignore that, because your acceleration in the x direction is 0. So that gives us a formula, and hopefully you have a calculator, because I don't have mine with me right now. But you can get a value for this. So you should get 5.5 meters equals whatever this value is. Plug it in your calculator. A value, vi t. And what you're going to want to do is, I recommend solving for vi, but you can solve for either one. And you're going to go over to your other formula you make. So you have it for the y direction. D equals vi y t plus 1/2 a t. This is a y t squared. Just plug in. I guess this is a y. This should be an x. And this should be 0.7 meters equals vi sine theta, which is actually 36. I guess we can plug that in, which actually equals 36 degrees. Close that out. T plus 1/2 AYT squared. And this AY you should know is negative 9.81 meters per second squared. I guess I'll plug it in. Negative 9.81 meters per second squared. T squared. Now, you're going to rewrite this, solve for, I believe I said VI, and plug it in. And it's that easy, guys. System of equations.